Hello, Mrs. Houston here with our Regents review. Number 21, which representation yields the same outcome as the sequence defined recursively below? Okay, so a recursive sequence, basically what we have to know is that this is telling us, this a sub 1 is that this is the first term. Okay, so the first number in the sequence is 3. All right, and then the next part of this formula here tells you to get a sub n, which basically means any number. To get any number, you're going to do -4 plus a sub n minus 1. So you're going to get any number, you add -4 to the number before, or the term before, number before. All right, so if my number before is 3, to get the next term of the sequence, I am going to get a different color here real quick, -4 plus 3, because that's the term before. So -4 plus 3, it's -1. Okay, now we're going to continue that pattern again to find the next term in the sequence. This time though, I'm still going to start with this -4, but this time the previous term is -1. It's not 3. So I'm going to do -4 plus -1, or -4 minus 1, which is -5. Okay, and then you can keep continuing this pattern. All right, start with the -4 and add it to the previous term, which in this case was -5. -4 plus -5 is -9. One more time, -4 plus, which number are we going to add it to this time? Right, it's the -9, the previous term. You don't go back more than one term, you just go back one. So that -9, which would give us -13, and so on. Okay, so if you take a look here, what we just did matches choice 2 exactly. And then I just wanted to show you one other thing with these two. We can put them into the calculator, and we're just going to put in an x instead of n. And then when we look at the table, we want to start at number 1. That's like your first term. All right, so they both start with 3, but then they go 7, 2, 11, 1, 15, 0. Okay, so those ones do not match what we just came up with. All right, question 2. If the zeros of the function g of x are -3, 0, 4, which function could represent g of x? All right, zeros. Okay, that is where y equals 0 if you're looking on the table. Okay, so you would look for this. Oops. We would look for a -3, 0, a 0, 0, and a 4, 0. That's one way to find the zeros. And then the other way to find the zeros is to see where does the graph touch the x-axis. Right here and right here. The x-intercepts are where y equals 0. So we have 3 of them here. That means we'd be expecting this graph to go through the x-axis 3 times. All right. When we look at our answer choices here, we see g of x in every single one. So that means we're using our y equals. Okay, clear out whatever you have in there and type it just like it looks, x plus 3 inside parentheses, x minus 4. Okay, I think the easiest way is probably just to look at the graph real quick. And notice this one only touches twice like the one I drew. So that can't be our answer because we need one that is going to touch 3 times. We have 3 zeros. Okay, so let's go back, and actually I know then that I can cancel this one out too because that is also going to be a quadratic function. Okay, 3 and 4 have an extra x over here. So real quick here, I'm going to try to be sneaky and insert the x in front. x times x plus 3, x plus minus 4. Looks good. All right, graph. All right, so this touches at -3, 0, and 1, 2, 3, 4. This looks like our answer. Okay, and just to be able to show you the answers with my pen, this here is -3, crosses right here at 0, and this is 4. Ding, ding, ding.